We're going to continue our study with curvilinear coordinates. And since the background of my students have been different levels, I want to make sure everyone's on board. So I'm going to go over these things which some students may already know about. Well, let's look here at curvilinear coordinates. And we have here basically the big three. The big three things we want to work with are the gradient, divergence, and the curl. These are very, very important in engineering and physics. And a nice spin-off effect of general relativity is that you're studying something so deep and complicated and advanced, general relativity, that on the way we learn lots of tools that can help us in other fields. So we have the gradient, the divergence, and the curl, and we have then the divergence theorem and Stokes theorem as two theorems that are related. So what are we really looking at here with these three? Well, if you think of this del operator as defined as the partial of something with respect to x and then I hat plus the partial of something with respect to y, j hat, and partial of the same something with respect to z, k hat, that is your gradient. So here we've used f as that something, the function, and it promotes, the del operator promotes a scalar into a vector. See, that f has no direction. It's just a function of x, y, and z. But when you take the gradient of it, you get a vector with the components I hat, j hat, and k hat. So we're going to ask you here to do a homework problem to actually calculate some things with the del operator, and one is going to be called here the divergence. The divergence, by definition, works on a vector, and it does so by taking the partial of the first component of the vector with respect to x and adding it to the partial of the second component with respect to y plus the partial of the third component with respect to z. So that is an assignment for you to do. And then the curl, this del cross b vector, this is defined in a similar way that you may have studied with your cross product. So the definition here with the I hat first is to take the partial of z with respect to y and subtract then when they're flipped around and so on. So I am assuming you have seen the cross product and will recognize this as a similar formula. So I'd like you to do that, and I have an appendix at the end, which I'll go over eventually at the end of this chapter, which will help you review some basic things with your vectors. Next, we'll start the divergence theorem in our next lesson.